It seems like everyone wants to get to space, return to the moon, or even set foot on Mars. But you need, for lack of a better vehicle, a rocket to get there. Now you might wonder, what is a rocket? If you ask me that, I'd have two answers. First, what do you live under a rock? And second, a rocket is an Thank you. A rocket is a cylindrical projectile that can be propelled to great heights or great distances by the combustion of its contents. Invented in 9th century China during the Tang dynasty, shortly after the discovery of gunpowder, sometimes called fire arrows, rockets are essentially a reverse of guns. But I'm sure you're here for more than just hearing that. These days, there are currently 3 types of rockets around the world. The first is the most faithful to the original invention, fireworks. The second is used how the Chinese intended their invention of the rocket, missiles. But the third one, which is the focus of this video, being the more recent and most inspirational use case of rockets, spacecraft.
Start, 2, 1, booster ignition, and liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond.
Now let's break down what a spacecraft is into 3 parts. Part 1. Why is it so dang huge? You may be confused why a few astronauts or a small or big satellite need a skyscraper to go to space. Well, the reason why these rockets are so big is to fit all the fuel needed to get into space. Also, why many rockets, apart from, say, the space shuttle, look like massive wedding cakes is due to staging, which we will get to in a bit. But just remember, when you see this image, the little bit on the top is the payload. The rest is just fuel to get it to where it needs to go. Part 2, the rocket equation. Now, calling something rocket science does not mean it's simple, but I'll do my best to try and simplify what the rocket equation is. This method is what most rocket engineers use to calculate the velocity of the mass of the total rocket including the mass of the payload and the fuel, minus the mass of the fuel that is departing the rocket, due to it being ignited and thrusting the rocket forward. As Isaac Newton says, every action has an equal and opposite reaction. Now, the rocket engineers use the rocket equation to figure out how much rocket they need to get their payload to their desired destination. Part 3. Orbit. If you watch any kind of sport where a ball is kicked or thrown over large distances, you'll notice how it flies in an arc rather than a straight line. This is due to gravity pulling the ball towards Earth and the ball losing momentum from the throw. If the ball were to not lose momentum, it would completely circle the Earth until it came back to where it started and probably continue. That, my friends, is called an orbit. For rockets to achieve orbit, they have to go crazy fast and extremely high. That's where stages come in. The parts that make most rockets look like tall, slender wedding cakes are designed as such to follow the rocket equation to get to orbit. Each stage lifts a lighter and lighter mass to gain higher and higher arches until the payload can go into orbit through its momentum. Now, how you go about building your rocket may vary. Generally, they all follow these same concepts, and if you follow them correctly, your payload will reach its target, hopefully being space. So, what is a rocket? It's an ancient invention that can bring us to the stars. That being said, thank you so much for watching. If you enjoyed the video, consider liking and sharing with a friend. And if you want to see more from me, subscribe today. And I will see you next time. Bye, everyone.